So many of you hear the word science and cringe. You all probably think of science as this major thing with math and bubbly stuff that you don't understand that is a lot of work and too hard. Yes, science fair can be hard work, and science can be too, but it's not too hard. It's all around you. Science is life. Without the principles of science, you would not be here. You're doing science as you breathe, as you write, and as you play video games. Science, technology, engineering, and mathematics, or STEM, are really the basis of the lives we live today. Each one of these principles is related to everything that we do every day, and they are each connected to each other. Math is the language of science, technology, and engineering. Now, how does this connect into Science Fair? Science Fair is the demonstration of the practices of STEM. Not everybody will be able to cure cancer. That is not everybody's deal. Everybody has an interest in STEM. For some, it's curing the diseases of the world. For others, it's how to make a better video game. Some want to help soldiers on the battlefield, and others want to save the environment. Some want to explore the stars, and others want to find alternative energy sources. Everything starts out as a project, and they start out small. This is your chance to make an impact on your future, the community, and the world. Yes, with a little science fair project. It should also be noted that many of the students who perform these projects are just like you. They're not all honor students, they're not all adults. They're all people who start out just like you. You may wonder how you're going to do this. The best projects come from everything you experience around you. The best projects are the ones you have an interest in and are willing to do. Otherwise, the whole project just becomes boring and you'll find yourself really not wanting to do it. That's how people begin to hate science. Know that there are certain projects that we will not allow at the fair. Volcanoes are at the head of that list. We also discourage product testing projects and projects done directly off the internet without any adjustments. Pre-made projects are old. We don't want to know what the internet knows. We want to know what you know. We want you to show that you can think. You could take an already existing project, but you need to add to it to make it better. We recommend that you look through online journals, magazines, the news, and around you for your project. These can provide a really good idea of a question you will want to ask. All projects start with a question or a problem to solve. You can also write down 5 things you like or have an interest in, or 5 questions you have always wanted to have answers to, and ask for help from teachers or instructors to narrow it down. Once you narrow it down, you then have your topic. From your topic, you can word it as a stated problem or objective. Remember, there are guidelines for experiments. These guidelines are meant for the safety of you and others. Human experimentation is a no-no. So is experimenting with animals that have a backbone known as vertebrates. No experimentation on Fido or Fluffy. You can't experiment on your own pets, brothers, or sisters. You can't do bacteria at home, and there are certain chemicals and projectiles that we will need to talk to you about or watch you before you begin. Your teacher will want to lock down your topic and will send the science fair office a list of your topics. You may have to come talk to the science fair office to see how to make the project happen. Once you have a problem or objective, then you can start your research. Traditionally, you can start with 5 research words that will help guide you. These really should not be definitions, but words that help you search for things related to your topic. Looking for your problem on Google is not the idea, and if your exact project appears on Google, then you may have to look for a new project. The idea is to take a new approach to the project and to make sure that you are not copying somebody else's work. You can take your research words to dictionaries, encyclopedias, and online search engines to look up information about your subject or subjects that you plan to experiment on. We can't stress this enough. Make sure that you have a logbook. We prefer composition books, but small notebooks will do, just as long as there is enough room for all that you will need to do. Logbooks are traditionally set up with a brainstorming for the topic up front, followed by the research, 10 to 20 pages for that, where you can write down what you read in your own words so you can put it in your report later. Then you can put your full problem, hypothesis, and theory in, leave 3 pages for procedure, 1 page for materials, and then the rest for data until you are done. Then use your logbook for data analysis and conclusions. You can put your name on the inside cover, but be prepared. It will be covered. Make sure that you properly cite everything. Plagiarism is grounds for disqualification. Once you have done your research, you are ready to produce your hypothesis, which is an educated guess about the outcome of your experiment. This is where you print what you think may happen. Hypotheses are never right or wrong. After that is a theory, which is actually more like an introduction or the reasoning why you're doing this project, as well as supporting your hypothesis. New rules state that you have to provide reasoning for conducting your experiment, and I did it for the grade doesn't cut it. Everything you put into your logbook will go into your report. It will just go into different sections. Once you have your question, hypothesis, and theory, you are ready to produce your procedure. This can be done with help from your teacher and instructor, step by step of how you proceed. You can also determine what materials you will need to complete the project. Sometimes you may have to bring these supplies in. Others, we may have them in the science fair lab or can order them. Once the procedure is ready to go, so are you. You can then go on to experimentation.